Hello students, in this video we are solving JEE Advanced problems of 2025. So we'll be discussing paper 1, section 1 in this video. Section 2 we'll be discussing in next video. Now let us look at the first question. Let R denote the set of real numbers. Let AI and BI belongs to real numbers for I is equals to 1 to 3. Okay. There are three functions f, g, h from R to R. And f of x equal to a biquadratic function, g of x is also a biquadratic function, h of x is okay, a combination of those two functions. If f of x is not equal to g of x for okay, then find the coefficient of x cube in h of x. So we just need to focus on coefficient of x cube here. H of x is nothing but f of x plus 1 minus g of x plus 2. F of x plus 1 is a1 plus 10 of x plus 1 plus a2 of x plus 1 whole square plus a3 of x plus 1 whole cube plus x plus 1 whole power 4. We are focusing only on x cube coefficient, so we will not be getting any x cube here in the second term, and in the third term we will get x cube coefficient in fourth term, which is while using a plus b whole cube we'll get only x cube, right? So we'll get a3 x cube, and here we will get 4x cube. So the x coefficient in f of x is a3 plus 4. Okay, now let us look for g of x plus 2, which is minus of, should we keep minus? Okay, let us leave the minus and solve for g of x plus 2. G of x plus 2 is equal to b1 plus 3 of x plus 2 plus b2 of x plus 2 whole square plus b3 x plus 2 whole cube plus x plus 2 whole power 4. So we will not be getting any x cube terms in these first three terms. In fourth term, we will get bx cube, and from this last term, we'll get 8x cube, right? 4 into x cube into 2. Yes. So the coefficient of x cube here is b plus 8. Yeah, that's it. So in general, we will be getting coefficient of x cube in h of x is equal to a3 minus, what is it? b3, right? Yes, a3 minus b3, and 4 minus 8 is minus 4. This is our coefficient. And now let us look at the main condition, which is f of x is not equal to g of x. That means f of x minus g of x can never be equal to 0. It has no real solutions. But what is f of x minus g of x here? F of x minus g of x is a1 minus b1 and plus 7x plus a2 minus b2 x square plus a3 minus b3 x cube. Since this is a cubic equation, f of x minus g of x is this is f of x minus g of x. This is a cubic equation, will definitely have one root. So if coefficient of x cube is equal to 0, then we won't be having any solutions. So from this we can conclude that a3 minus b3 is equals to 0. So a3 equal to b3. We substitute it in our coefficient, is becomes 0. So the coefficient of x cube in the given function h of x is minus 4. So the answer is option C. Now let us look at question number 2. Three students S1, S2 and S3 are given a problem to solve. Consider the following events. There are four events here. Okay, and these are the probabilities of three of those events. Then P of t is equal to probability of three. So the first case is at least one of the students S1, S2, and S3 can solve the problem. So at least if at least one of them solves the problem, that means the probability of event where E is event of no one solving is equal to 1 minus probability of 3, that is 1 by 2, which is equal to 1 by 2. That means if let us write down all the cases, possible cases. So S1, S2, and S3. The tick mark means solving the problem, and into means not solving the problem. So let us write all the possible cases. So you will get all three, then this and this, and where only S1 solves the problem. These are first four cases where S1 solves the problem. Now let us take four more cases where S1 does not solve the problem. So you will get tick and around here, tick, tick, down. Since we know that probability of not solving the problem is 1 by 2, and P of V, what is V? V is a event where S1 can solve the problem given neither S1 and S2 solve the problem. So it is this case whose probability is 1 by 10, and W. S2 can solve the problem and S3 cannot solve the problem. So let me take blue color here. So here S2 can solve and S3 can't. One more event here also S2 can solve and S3 can't solve the problem. So probability of these two events happening is 1 by 2. So you are left with these cases where S3 will definitely solve the problem. If you look closely, these are the cases where S3 can solve the problem. So let us assume probability of these four cases is equal to X. And we know that sum of all probabilities is equal to 1. So X plus, we are done with this, and this. And let us take these two, which is 1 by 12 plus this is 1 by 10. And the final case is 1 by 2. That should be equal to 1. So X is equal to 1 minus 1 by 2 is 1 by 2 minus 1 by 12 plus 1 by 10 is 22 by 120, which is equal to 11 out of 60. So if you take 60 as LCM here, 30 minus that becomes 19 by 60. So the probability of event where S3 can solve the problem is 19 out of 60. Now let us look at question number 3. Let R denote the set of real numbers. Define the function f R to R. F of x equal to this. Then which of the following statements is true? Okay. Now let us look at the first option. The function f is not differentiable at x is equals to 0. For the function to be differentiable at x equal to 0, the first condition is it should be continuous at x equal to 0. So let us check whether the given function is continuous at 0. If we substitute 0 here in the first case here, then we are getting 2 minus 2 of 0 square minus 0 square into sine of 1 by 0. This is oscillator function, so this becomes 0 here. So you'll get f of 0 as 2, and that is correct here in this case. So f is continuous. So let us check it. Let's check for differentiability. So if I differentiate f dash x, what will I get? I will get f of h plus x minus f of x by h, limit h tends to 0, and I am differentiating at 0. So f dash 0 equal to limit h tends to 0 f of h minus f of 0 upon h. F of 0 is 2, so I will write 2 there. F of h is 2 minus 2 h square minus h square sine 1 by h minus f of 0 is 2 by h. So 2 and 2 gets cancelled here. If you take h common, 1h and 1h gets cancelled here. You are left with h of something. H is 0, so you will get 0. So f dash of x is 0. And for the second function, it is also equal to 0 because it is a constant function f of x equal to 2. You will get 0 differentiation. So this option is wrong because the function is differentiable x equal to 0. And let us look at option B. There is a positive real number delta such that f is a decreasing function on the interval of 0 to delta. Let us check whether the function is decreasing or increasing at 0. So how to check that? First, f dash of 0 should be less than 0. That will give you uh, the conclusion that function is decreasing. Okay. So what is f dash of x here? F dash of x is nothing but, let us differentiate the numerator, this first function. So we'll get 0 minus 4x minus, if we differentiate x square sine 1 by x, we'll get 2x sine 1 by x plus x square cos 1 by x into minus 1 by x square. So this is equal to minus 4x minus 2x sine 1 by x plus cos 1 by x, not plus, minus. Okay. Now this becomes 0, this becomes 0, but cos 1 by x, as x tends to 0, this f dash of x becomes oscillating. It oscillates. So we cannot judge whether it is a decreasing or increasing function at 0. So the second option is also wrong. Now let us look at the third option. For any positive real number delta, the function f is not an increasing function on the interval minus. So this is correct actually. It is not increasing or decreasing. Okay, then let us look at option D. X equal to 0 is a point of local minima of f. So let us look at f here closely. I will erase this part. So let us look at the fourth option, at x equal to 0. Okay. If you look closely at the function, it is 2 minus, if you take x square common, you are left with 2 plus sine 1 by x. That's right. That's it. So we know that sine 1 by x, its range is from -1 to 1. So at minimum, we will be getting 2 minus x square, and maximum will be getting, if we substitute maximum here, then we will be getting 2 minus 3x square. In both the cases, f of x is less than 2. In both the cases, f of x is less than 2. That means f of 0, you will be getting 2, right? So every other value is less than 2. So at x equal to 0, 2 is the maximum value. So it is the local maximum, not the local minimum. So it is wrong. So the answer is only option C. Now let us look at the last question of this video. Consider the matrix P is equals to, it is a diagonal matrix with elements 2 to 3. Let the transpose of matrix X is denoted by, okay. Then the number of 3 cross 3 invertible matrices Q such that Q inverse is equal to Q transpose and PQ is equals to Q. Okay, let us assume a matrix Q is equals to A, B, C, D, E, F, and G, H. So we told us PQ is equals to QP, right? So from that we can write it as 200,020,003 into A, B, C, D, E, F, G, H is equal to A, B, C, D, E, F, G, H into 200,020 and 003. So here we'll get 2A, 2B, 2C, 2D, 2E, and 2F, 3G, 3H, 3F. And here we'll get 2A, 2B, 3C. Okay. So we'll get 2D, 2E, 3F, 2G, 2H, 3F. By comparing these two matrices, we can conclude that C is equals to 0. Since 2C equal to 3C, similarly F and then H and G is also equal to 0. So our matrix, in our matrix, A, B, C is 0, F is 0, and what else? C, F, G, H. These two are also equal to 0. Okay. And one more, there is one more condition. We set Q equal to Q transpose. That means Q into Q transpose is equal to identity matrix. What is Q? So A, B, 0, D, E, 0, 0, 0, I into, if we transpose, we'll get A, D, 0, B, E, 0, 0, 0, I. And this should be equal to I. So A square plus B square and then AD plus B and then 0. Here we'll get once again AD plus B, then D square plus E square equal to 0. Okay, D square plus E square, then 0. Here we'll get 0, 0 and I square. This, since this is equal to identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, we can clearly say that I square is equal to 1. I square is equals to 1, that means I is equals to plus or minus 1. Okay, what else? We can say that A square plus B square equal to D square plus E square equal to 1 and AD plus B is equals to 0. Okay, so let us look at this equation 2. From this we can write D is equals to minus B by A. If we substitute this in this equation, we'll get B square by A square into E square plus E square equal to 1. So E square of A square plus B square by A square equal to 1. We know that the numerator is equal to 1. So E square is equals to A square. That means E is equals to plus or minus A. Okay. If we write the same thing in different way, E is equals to minus A by B into D. Then we'll get D square plus A square by B square, D square equal to 1. So D square of A square plus B square by B square equal to 1. This is 1. So D is equals to plus or minus B. That is one more conclusion that we are getting here. So the final matrix is Q is equals to A, B, 0, and D is nothing but plus or minus B, and E is nothing but plus or minus A. This is 0, this is 0, this is 0, this is I, which is plus or minus 1. And for the condition A square plus B square equal to 1, and we are using only integers. So if A is 0, then B is 1, or minus 1. If A is 1, then B is 0. If A is minus 1, then B is also 0. These are the four values possible for A and B. And for every value of A and B, we can get two different values here because we are using plus or minus. So we'll get 4 into 2 because of this plus or minus. And here there is plus or minus 1. So we'll get into 2 times the values. So the total number of solutions are 16. Okay, now once again let us check the 16 values. So 1, 0 automatically, so this becomes 0. Then this is 1 or minus 1. And if it is minus 1, then we'll get same values minus 1, 1, and minus 1, minus 1. Same thing can be repeated for B. So 8, 8 into 2, 16. Yeah, that's it. So the final answer is 16. Okay, that's it for this video. In next video, we'll discuss section 2 of this paper 1. So subscribe and stay tuned.